Hello and welcome to this new Java programming language course. In this course we will learn all about the Java programming language. So to start with the course, you would have first to be able to compile Java code and to have a text editor. So you will have to install the Java Jdk, so the Java Development Kit, right? So it's really easy. It depends on the operating system you're using. You basically go to Google and search for download the JDK, and then you will select your operating system, whether it is Windows, Mac OS, Linux, or whatever. The thing is that with Java, it doesn't really matter in which operating system you're using it, because it runs in a virtual machine, so it's the same for every operating system. So once you have installed it, in this case I will be using Visual Studio Code in a Linux operating system. In this case I'm using it on Debian, but it will work the same for Ubuntu or whatever other Linux distribution. So this is Visual Studio Code. This is a free text editor, code editor for almost any platform out there. You can also download it in Windows, Mac OS, or Linux. And so after you've installed the Java Development Kit, you should be able to open a terminal and type Java. And if you type enter, kind of these options should appear. And if you type Java C, which is the Java compiler, these options should appear. So before going forward with the tutorial, make sure you have Java and Java C installed, right? So basically Java is a high-level object-oriented programming language that runs on a virtual machine. This means you don't need to recompile your code if you run it on a different architecture, right? Okay, so Java basics are kind of about objects. Objects are kind of pieces of code that have certain states and behaviors, like maybe a person has a name and has a weight and has a, something, right? Characteristics of an object. And we also have classes, which is kind of a template that describes the behavior of the object and the type of it, right? We also have methods that basically are procedures that we can call of a behavior of an object, right? So a class can contain many methods, okay? And we also have instance variables. So each object has its own set of kind of instance variables, and an object state is created by the values assigned to these variables, right? So we will start coding right now. We will open Visual Studio Code and we will open a new folder. In this case, my folder here is Java Tutorials. If you don't know how to open a new folder, you simply go to File, and here you go to Open Folder, and you basically create a new folder. Like right here, I have created this Java Tutorials folder. If I open it, you can maybe create another one. Maybe I will create one that is Java code, okay? And I will press in OK, and now the Visual Studio Code will open this folder. So right now we will create a new file by clicking on this icon right here, and I will call it Java code, right? So I will call it Java code that I call it that Java, okay, or that class, okay. So maybe I will use that class, right? I will press enter, and right here we can see that our first source code file was created. So first of all, every Java source code has to start with a class, right? So you can start by typing public class I will call this Java code, right? I will open brackets, okay, and once that I have opened brackets, I can write the remaining stuff. So inside the class, we can write the methods, and in this case, since we're using kind of pure Java, we want to write the main method, okay? So you're gonna say public static void main, okay? We open parentheses, and inside these we will put string a string array, okay, a string array, and args, which are the arguments that might be passed to our program, right? So that's kind of the starting point for us to learn how can we structure a Java program, okay? So we have a class right here, and inside the class we have the main method. So please write the main method as I'm doing, and now we're gonna print something to the screen. To print something, we're gonna say system that out that print ln, okay? We'll open parentheses and we will type hello world. So this will be our hello world program, okay? And we have to end this line with a semicolon, right? Okay, so now our source code file is ready. For convenience, if you don't have the autosave feature enabled, you can enable by going to file and then click here in autosave, right? So you won't have to be saving every time you change or you make changes to your source code file. Okay? So now that the file is saved, we can compile this program, right? So to open the terminal in Visual Studio Code, we will press Ctrl and the key that is just below the escape key, and the terminal, as you can see, will be opened, right? So here what we will write will be the following. We will write Java C, and we will write Java code that class. And after we've done this, there's an error, so maybe we don't have to use the that class suffix right here. We will change the name of the file to .java. So I was confused about this previously. So it's actually javacode.java. So we will rename our file right here, okay? And we will say Java C, and then we will call it javacode.java. And after we've done this, it still has some syntax errors right here. Oh, you know what? I think the problem here is that the name of the class should be the same name of this inside class. So this starts with an uppercase J, right? So we also have to use that uppercase J on the name of the file. So let me define this. So to uppercase J, and now we will run it again, and apparently we'll still have a problem. So let me see. If we press Java C, okay, Java code, oh, I'm not using uppercase here, so we'll use uppercase here. And what it says, it's saying invalid flag Java code that class, but it's not that class, it's Java code that Java, right? So once we've done this, we have an error right here, which is a typo error I just did. So instead of system, I forgot to put an M right here. So let's try it again. And now we still have an error right here. It says Java code is public, should be declared in a file called Java code. Okay, so again, so this is pretty important. We right here as the name of our class, you should have the same exact name of your file. Okay, so if it's just the J is the only uppercase letter, then it should be the only uppercase letter and the code won't be uppercase, right? So now if we run it, it's actually finally compiled after lots of errors, right? So again, to clarify this, we use Javac because this is called the Java compiler, right? And as the file name, we have to have the same file name as we have in the class name, right? Okay, let me delete this other file I won't be using. Okay, so delete. Okay. Okay, so again, Javac and then Java code.java. We press enter and the program is now compiled. Now, how do we run that program? Well, to run this program, we will just say Java, okay? And then we will say Java code, okay? So, notice that here I'm not using Javac anymore. I'm just using Java and then just saying Java code. Why not .java? Because the .java is the source code file and this is the executable file. If we see which files do we have, we can see that we have the Java code.class, which is equivalent to just Java code, and we have Java code.java, right? So we have those two files basically, and now this is how you create a simple Hello World program for Java, right? So as I told you, Java is case sensitive, right? So you have to be aware of the cases, so to avoid the errors I just made previously, okay? So that's how a simple Java program works, right? So let's go back to the Java source code to learn a bit more about it. The first word we have, it says public. So what does public mean? Well, basically, public is a kind of a identifier that enables us to know how accessible an element is, okay? So it can be public, private, protected, right? So what does it mean? If it's public, it means it can be accessed from the outside world, right? If it is private, it means it can only be accessed from inside the class, right? Kind of from the inside world, if you want to talk that way. And if it's protected, it can be it can be accessed from inside the package, which means imagine a class is your house, right? And protected means that it can be accessed by the other houses in your block, okay? Public means that it can be accessed by anyone in the world, right? And private is that it means that it can only be accessed by you or by other house or family members, right? Okay, so this enables us to restrict access or to allow access to different instances of a program, right? Okay, so we also are able to have local variables and arrays and all kinds of different data types that we have on another programming language, right? Okay, so then we have this public static void, which means this is a method that returns void, which means doesn't return anything. Absence of type basically means void, and static means that it is exists only statically in memory. So this means it can exist as if we have a static variable, we can keep the function, the value of the variable between function calls, right? Okay. So, and we can also write comments in Java. To write comments, we start with / and we will say, hello, I am a comment, right? So this is basically how we write comments. And we also have multi-line comments, if we want to write more than one line comments, we say slash asterisk, and then we will close with asterisk slash, and inside these two kind of blocks we can write whatever we want in multi-lines. Okay, lots of comments, right? So we have single line comments and we have multi-line comments, right? Okay, so now we also know how to print out to the screen, which uses the system out println, which is a method that is available to us as part of the Java language in order to enable us to print to the screen, right? So, what are objects, right? Well, like in the real world, we have different objects like tables, chairs, cars, whatever the case may be. For example, if we consider an animal like a cat, for example, we have that the state can be, maybe it can have a name, it can have a size, it can be of a certain color, it has some behavior like making cat noises, right? Or liking to play with anything basically. So an object defines how that object behaves and the characteristics of it, right? So Java is an object-oriented programming language, right? So if we want to define a dog, for example, right, how can we do it? So first, we can create an inside class inside this to define a dog, or we can also create something outside this class, right? So if I create something outside this class, just after the class bracket, I can say public class dog, for example, right? Okay, now what I just did is creating a dog object that will enable me to define it as a different sort of behaviors and characteristics and features that a dog has. For example, inside the class I would say string breed to store the dog breed, right? So a string is basically a data type that enables us to store a sequence of characters, like a sentence, right? Or a word, or a paragraph, that enables us to store text, basically, right? So that's a string. We also have int, okay? So what is an int? Well, an int is an integer value, which enables us to store numbers, right? So maybe the int will be the age, right? So I'll say int age, okay? Okay, and maybe we want to also define the color of a dog. So I'm going to say string color. Okay, so that's how we define stuff right here. We can define maybe the weight using another int, but if we want to be more precise, and instead of using integer values, we want to use floating point values, we can say float and define a dog's weight, right? Okay, so float weight, okay, maybe in kilograms or pounds or whatever the case may be. So this is how we define a dog element. We also can define some behaviors of a dog. For example, barking, right? So I'm gonna create void, I'm gonna say barking, and we're gonna open here, and now we have a new behavior that the dog is able to bark. So that's basically how we define a dog. You can extend this dog class by adding more features and more variables and more methods and so on, right? So this is basically how we can use this. Now, we will learn about constructors. So we will talking just about classes, but a very important part of classes are constructors. So every class has a constructor. If we don't write a constructor for a class, the Java compiler will build one, right? Okay, so every time a new object is created, we have to somehow have a constructor, either implicitly or explicitly, but we have to, right? So constructors are just about that they should have the same name as the class. And of course, a class can have more than one constructor, right? So let's understand how a constructor can work. So we have public class dog, right? So the constructor method for dog would be public dog, right? And that's the constructor method, okay? But we also can have more than one constructor, right? In this case, it would be, for example, public dog, but in this case, we can have a parameter here, which are values that can be passed between methods, right? Okay, so you're gonna say string name, for example, right? So we can initialize the dog with a name, okay? Okay, so this is basically how constructor methods work inside classes, right? So pretty easy so far, right? So now, how can we create an object? How can we create an object? So maybe we want to create an object inside our main method right here, up here. If we want to create a dog, how do we do it? Okay, so after we print hello world, we will say something like dog, and I will call it my dog as a name, okay? And when I do this, I can either create and call a constructor, like to create a new element, we type new and say dog, for example, right? Okay. So in Visual Studio Code, we can also install a code formatter for some programming languages. So let me see if I can do it now. So I will click on install formatter, and let's see if I can have a sort of a, okay, right here. So I will install the first one that appeared right here. What this will enable us to do is it will basically kind of color the code out and enables us to ident and order the code, and depending on the plugin it may have different features. So this is kind of an advantage of using Visual Studio Code, because we can download these additional plugins and make our lives a lot easier, right? So right now, as you can see, it's being installed. If you want, you can also install this. I'm using this language support for Java by Red Hat, which was the first that appeared in my list. So it looks very popular. It has kind of a 15 million downloads, so it should be good, right? So now it says installed, okay? And it says, do you want to include VS Code, Java project settings, files, and all of this? And I'll say, you want to exclude? No, I won't want to exclude. Okay, because by only syntax errors will be reported. Okay, not a problem. That's okay. So now, if I go back to my source code file, I can see that it has some colors coded right here, so which is kind of nicer. As you can see, these strings are now in red and the other in blue, and some green for the comments and so on. So basically, this is how we create a new element. So we'd say my dog is set to new dog, okay? So, and maybe I can also call the other constructor by saying dog, my dog with name, for example, and I will call new dog, and I will pass the name of the dog. In this case, it will be max. Okay, so capital M, right? So what I'm doing in the first case is I'm just calling new dog. This means this will go down to this plug, to this class, and we'll call this method right here. But in the second case, I'm calling new dog with a string parameter, with the dog name. So it will be called through here, right? So this is how we can access an object and create an object, and then maybe access with the different parameters. Maybe we want sometimes to create a dog with a name, maybe with an age, maybe with or without color. So it really depends on how we can do this, right? So now, what if I want to make the dog bark, right? How can I do it, right? So if I'm right here, after I have created my dog or my dog with name, I can say my dog, and then I will type a dot, and as you can see, I can set the dog age. So I would say dog age will equal to 10. Okay, but I can also call a method, so I can say my dog dot barking. Okay, so if I call this method, the dog will bark, right? If I have set that here. For example, I can make that by saying system dot out dot print ln. Okay, so this print ln is the same as we did here when we printed hello world, right? So print ln, and we will say barking, right? Or something like that. Now, if we compile this and run, so I'm gonna say Java C, and then say Java code.java, and it will be compiled, and here we have an error. As you can see, it says dog is public, should be declared in a file named dog.java, right? So this says that the dog class should have, so the dog class should have its own file because it's public. So what if I want to make it private, right? Or nothing, no modifier at all, right? So if I don't use any modifier and I go again, and I can see it is now compiled, right? So to run these, I will say Java code, and as you can see, it says hello world, and then it says barking. Why does it say barking? Well, because we're creating a dog object right here, and we're calling it the barking method of the dog, right? So that's how we can call different methods and access different ages, or in this case, we're accessing the age, or different data types, and so on, right? But we can also create a method that will enable us to maybe set the dog age in a programmatic way, right? So we go inside the dog class and we'll say public void set age, for example, and we will pass an int right here, so int age, right? And what we will do here, it will set age. Okay, let me see. So I want to access this age variable from here. How do I do it? So to access a variable from outside, we will do the following. We'll say this.age, okay? This.age, and we'll set that to age, right? Okay, so what does it mean? This refers to this class, right? So when I say this.age, the age I'm referring to is not this one, but this one, because I'm referring to the age that is inside the dog class, right? So you can say this class at age, and this will be set to the local age, which is this one right here. Okay, so if we compile it, it compiles great, so it works, right? Okay, so that's how we can set the age, but we can also get the age, right? So to get the age, we can say public void get it's not a void, it should be an int because it will return the age. So we'll say public int get age, right? And when we call get age, what we will return is return age. We can just return age, or we can return also this, that, age. It will return the same, but we don't have, because here we don't have another age to be confused, to cause confusion to us, right? So basically when we call this method from outside, like for example, if we say, we set the age here, the age, and then we say my dog that get age, it will return 10, right? So if I create an integer right here, int age, it will be set to my dog get age, and it will receive the number 10. So in this tutorial, we learned how to set up our Java development. We learned how to create classes. We learned how to create methods, how to print something to the screen. We learned how to access objects and call constructors and call different modifiers. And in the next class, we will keep learning about more object-oriented concepts. And I hope you enjoyed it. And I see you in the next one. Bye. Hello and welcome to part 2 of the Java programming language course. So in the previous tutorial we learned the basics of Java, how to compile it, how to fix errors, how to debug it, how to create objects, classes. And in this tutorial we will keep learning about these concepts, but we'll also learn about data types, integer and floating point data types, right? Okay, so if we continue experimenting with these, we have created a dog, then we have created a dog with name, then we have created we'll set the age of the dog, and then we call barking, right? So if you remember, if we compile the code, and if we run it, it says hello world, and then it says barking, which is exactly what we actually want. But now, how can I know if the age that I set here actually took effect or not, right? So I am calling this method right here, the int age. I will set it to my dog that get age method, which if we go back to the dog class, what this get age method will do, will return the age of the dog, right? So we will print this to check if it's indeed 10, okay? So to print it is very simple. So it's basically we say, and we call system.out.println, right? And inside here we will pass the thing we want to print. In this case, we want to print an integer. So to transform from a integer to a string, maybe we can do the following. So if we do nothing and just pass the age right here, right? And if we compile it and then if we run it, then the compiler is kind of smart enough. The compiler is smart enough to transform these into a printable way, right? So as you can see, it has the 10 value right here. So the age we just set right here, it's actually working. So if I comment this and I run it again, okay, then it is set to 0 because the default value of an integer is 0, right? But what if I want to set the age in an alternative way? How? Well, basically saying my dog that set age, and I will pass 10 right here, okay? So if I compile this and run it, I have 10. So here notice that we have two ways of accessing class members like the age, right? We can either do and say my dog.age is equal 10 or my dog.setAge, and we will pass the 10 value right here. So this is how we can basically call two things in a different way, right? In two different ways, right? So this is basically how this works. Now we will go and start learning about primitive data types. So we will start with integer data types. So after these multi-line comments, I will start writing how the data types in Java work. So we have the smallest one is called a byte, right? So a byte, I call it my byte, for example. I will set it to 0. So I will put a comment describing what a byte does, and this basically can contain different ranges of integers. So it goes from negative 128 to positive 127. This means that my byte variable can contain 256 possible values, and those values are between the ones I just specified right here, inclusive, right? Then we have a short. So short, I will call it my short. So all of these variables enable us to store numbers, basically. So byte, we can store kind of small numbers, right? With short, we can store a bit larger number, right? I will set it to 0 too. We can set it to 1000 maybe, because we really are able to store larger numbers in my byte, in my short. But in my byte, we cannot go beyond 127. So the largest number it can have is 127. So then we have my short. And the short data type is able to store values from the range starting at minus 32,768 to 32,700 and 767. So it can store kind of 65,000 different numbers. Okay, and we have also larger, like int. So an integer can store larger numbers, right? I will call it my int. Now we'll set this to 100,000, right? And what these can store, they are really big values. For simplicity reasons, it will start with negative 2 billion to positive 2 billion, right? And those are pretty big numbers. The integer is the most commonly used data type. As you can see, I used it to define the age of a dog. I used it to define basically the age, but that's how we use an integer. So integers are just numbers, right? And then we have longs. Well, a long is an even larger one. I'll call it my long, and this is just insanely large. So it goes from, I don't even know how to pronounce it, so let me see if I can actually figure out what this number is. So we have, let me see, million, billion, trillion, quadrillion, quintillion or something. I don't know, it's a huge number, so you can really store very large numbers in a long, which it's very hard that as you learn, you will be using those numbers, right? Okay, so it says that the literal of type int is out of range, but that's because the default way that the Java program handles large numbers is in integer. So if we want to cast these as a long, so it will be better understood by the program. So is this too large for a long? I don't think this is too large for a long. So maybe the problem here is that the thing of Visual Studio Code is not working as it should, right? So that's why this warning, we will ignore it because it's a kind of a bug of the system, right? So this is insanely large numbers. Oops, insert insanely large numbers, right? So that's what a long is able to do. Okay, just to make sure I didn't type an error, I will compile Java code.java, and it says integer too large, right? But somehow the thing is that it should fit here. Okay, we will figure this out later, but we will decrease this a bit. Okay, we will put it in 10 million or maybe 100 million or a billion even, right? So now if we write it again, it won't say anything. So it says integer number is too large, but well, I don't really know why this is, but it shouldn't be the case. But anyway, so long, we can store insanely large numbers, right? And we also have a char or a char, which is basically to store letters, right? So we can store different characters, like and letters of the alphabet or whatever characters we may want. So I'll call it my char. And to store a character, I have to do it between single quotes. For example, I put in R, for example, capital R, and that's my character. So how many characters, how many possible values this can have? Well, a lot actually. They can have 65,535.36. So actually it has values from 0 to 65,535. So this is basically how we can define these different integer data types that will enable us to store numbers, or in this case, a character, right? So let's compile it to check again everything is still working, okay? And yeah, it's still working. Now those are kind of these basic data types. And what can we do with these guys? So first of all, we can compare them, right? So we can check if a number is equal, smaller, or larger than another one. So to do that, we say if my byte is greater than 2, for example, and if that's the case, we will print something like, for example, print ln. Oh, I'm forgetting something right here. So system that out that print ln, and I will pass my byte is greater than 2, right? So if I run this right now, so let me check. If I run this right now, oops, we have something here. Okay, what's going on here? Let's check this again. So it says Java code that Java 36 illegal start of type. So why is this happening? So let me see. So here we have a problem. Token expected after this. So maybe here in the char we're having a problem. I don't really understand these. Let me check. A char. Okay, maybe this line is somehow causing a problem that I don't really get it. If I comment this line, just to make sure, then we'll still have some sort of a thing right here. And I'm just asking if my byte is greater than 2, then do just that. But apparently it's not understanding what I'm trying to say. I don't know why that is, but okay, if my byte is greater than 2, This is kind of strange to me, right? Okay. So maybe it's about the byte. So what if I go and test with my int? So if my int is greater than 2, and again, it's a problem. So if my int equals 2, and we still have a problem. And as you can see up here, we have an error token expected after this token, right? So maybe we have created an error. Oh, the problem is very odd actually. So we have to execute all of this inside the main method, right? So it won't work if we are executing it outside the main method. So we will move this code to inside the main method because we're kind of executing outside the universe, right? So we have to put it inside the main method right here, okay? And now I will go back to the original code, which is my byte. If my byte is greater than 2, okay, we compile it, and now it is working, and it says my byte is greater than 2. So this we can set to greater than 2, we can set to smaller than 2, and for example, if we set this to 1, if my byte is set to 1, and I will say my byte is less than 2, okay? If I compile it and I run it, it says my byte is less than 2, okay? So basically, this is the operation we're performing to compare if it's smaller, larger, or maybe equal to 2, okay? And we can, so we have smaller, larger, we have less or equal than, okay? We have also greater or equal than. So just these are the basics, and we have also different. So if my byte is different than 2, so this is what the different sign means, right? So that's basically, we can also perform operations right here, right? So we can, well, let me delete this, and for example, we can start doing additions, for example. And if I go and say for example, I will add 2 numbers, okay? So let's create an integer, and I'll say sum, and I'll set this to my int plus 6, right? Okay, so that's how I create an addition. And now if I want to print this, I'm gonna say system dot out dot print ln. Okay, I open this and I will print sum, right? So if I go ahead and compile this and then run it, it says the number of integer, which was 100,000, it now is 100,006 because I have added 6. Okay, we can add, we can subtract, we can multiply. To multiply, we use an asterisk. We can divide. To divide, we use a forward slash. So that's how we divide, basically. Okay, so yeah, so this is the basic operations we can perform. We can also have the modulus operator. Modulus operator is used with the percent sign, and what this does is basically it returns the remainder of a division. So it will divide my int by 6, but will return the remainder of that division. In case it's 0, it will return 0, right? So basically that is how these variables work, but we don't really have to perform these operations here. We can perform them when we print them, right? So instead of printing sum, for example, I will print my int times 3, right? So if I go and compile it, okay, and I run it, it is 300,000, right? Because it's 100,000 times 3, it's 300,000, right? So that's how we can do this, right? Now let's take a look at the floating point variables, right? So basically, what is a floating point variables? Well, it's pretty simple actually. A floating point variables enables us to store floating point values, right? So the most basic one is called a float, right? So you're gonna say my float, and here to specify a float, I will specify to 1.45, okay, and I will print this out. So you can say system.out.println, okay, and I will print my float, okay, and I will compile it, and so we have an error here. So to end these, we will end with an F to let the compiler know we are actually defining a float, right? So we compile it again, and now it compiles, and as you can see, it prints 1.45, which is exactly the number we want. So the previous ones were only for integers, and these ones are for floats. So the first float is this, which can have kind of 6 possible decimal values, okay? So if we add more decimal kind of precision, we also have them here. But if we want something beyond that, we have to create a double, so which is a double precision, right? So you're gonna say double, my double, okay? And we will set these to 1.345654345 or something like that, okay? And if we define this, we will compile it and we will run it, and I forgot to print this, so let me print this. So I'm gonna say system.out.println, and I'll pass my double, okay? So this is how we will print a double. So we compile it and we will run it, and here is how we have double precision floating point values, right? So that is how we can do this. So apart from the operations I told you previously, we can also decrement by 1 or something. For example, if I want to increment my byte with 1, so I want it to be 1 plus 1, how do I do it? Well, the first option would be my byte equals, which is assign my byte to my byte plus 1, okay? So which is kind of the easiest way to figure it out. But we can also have the following way, and we can say the Java language enables us to say my byte plus equals 1, right? If we want to add 2, we will say plus equals 2, right? So these two do basically the same, just it looks different, but do the same. Now, if I just want to add 1 in a simpler, even simpler way, I would say my byte plus plus. So, which means increment the current value of my byte to 1 by 1, right? So, if I want to decrement it, I would say my byte minus minus, right? And it will decrement. So, right, this one is pretty useful. The second option, because it can be used for different operations. It can be used for division, it can be used for multiplication, for modulus, whatever the case may be, right? So that's how we work with these new operations. Okay, we also, apart from these two, bytes and shorts, integers, floats, doubles, we also have a smaller kind of a variable, which is a Boolean. So a Boolean can either have on or off values, so it can be true or false, right? So Boolean, I will call it my Boolean, and I will set it to true, okay? It can be either set to true or false. This will enable to check some conditions. So we can say if my Boolean, okay? When we say if my Boolean, we're asking if my Boolean is true. And if it's true, we can execute some code. So execute some code accordingly, right? And if it's false, we can do something else, right? Whatever the case may be in our program, so do something else. So that's what Booleans can be used for, right? So pretty easy so far to understand this concept, right? The Booleans can also be checked with the same as we did previously, right? Okay, so we have learned objects, we have learned classes, we have learned data types. Okay, we have learned how to print some stuff to the user, and basically that is kind of the basic ways to learn how to program in Java. Now we will learn a bit about methods, right? So let's create a method that will enable us to kind of practice how this will work, right? I will leave the doc class there for a moment because we may use that later, but then I will delete all of these other stuff inside the main method, right? So don't forget to close the main method. Okay, and inside the main method, I want to call another method, right? So maybe I want to call a method that would say add numbers, right? So and that addition will return an integer, right? So you can say int add numbers, and now I will introduce you to parameters. So parameters are values like the ones we used here in the doc class, or these inside the parentheses int age, right? So our values that are passed between method calls to specify what do we require from the method, right? So for example, the first one will be an int that I will call n1, and to separate parameters we just put a comma. The second parameter will be an int again, and then 2, right? So we open this, and what we will return here. So when we say return, it says go back or send back something, right? So what we will be sending back will be the addition of n1 plus n2, because this is called add numbers, right? So we will return n1 plus n2, right? So how is this even useful? Okay, so from inside the main method, we're gonna create an integer, and I will call it sum, and I will set this to the following thing. I will set this to add numbers, okay, and I will pass as parameters 1 and 5, for example. So what this is doing, it is saying add these two numbers using these two parameters. So as you can see, we have a warning right here that says cannot make a static reference to the non-static method. So as you can see, this method is a static, but this one is not. So we cannot mix them both, right? So in order for us to be able to access this, we have to make these static. So I'm gonna make it a static, and now the warning has been disappeared, but now we have another warning right here that says token on static, delete this token. So let me see. So this is basically because we're using this main method that is kind of mixing us with this. So we don't say first int static, right? We have to say static int, right? Static int. And that is how we define a method. So first, you have to remember the order of the operations we want. So first, we have whether it's public, private, or protected. Then if it's a static, we will use a static, right? And then we will use the data type. In this case, is an integer, and in this case, is void, which is absence and doesn't return anything. So now, when I call the add numbers method and I pass the parameters 1 and 5, then these parameters, this one will be moved here to n1, and this 5 will be moved here to n2, and this will return n1 plus n2, and that result will be stored in the integer sum. So by the way, you have to receive the same type you're asking for. So if add numbers, when you say add numbers, it will return an integer. Okay, so we have to store that result on an integer too. So after we get the sum from the method, I will print it by saying system.out.println, okay, and what I'll pass to this method will be sum, okay, because I want to print the sum. I open the terminal and I type javac javacode.java to compile our source file, and then I type java code to run it, and as you can see, it prints the number 6 because 1 plus 5 is 6. Okay, so now in Visual Studio Code, that is a very useful tool to use. If you press Ctrl+Shift+I, it will format the document to make it more visually appealing and more ordered and structured. So that's a kind of useful tip too. So basically, we have learned a bit more about objects, a bit more about methods, a bit more about floating point values. And that's it for this video. I hope you enjoyed it, and I see you in the next one. Bye. Hello and welcome to part 3 of the Java programming language course. In this course we will learn a bit about how to typecast, which means how to transform one data type into another. Basically, we'll learn some how strings work, how switch statements, while loops, for loops, and that kind of thing. Okay, so let's start. So what is typecasting, first of all, right? So if we go inside our main function after we print the sum of two numbers we just did in the previous tutorial, we will go here and we will, for example, as you may remember, we have different types of variables, okay, of primitive integer variables. A very common variable is the int, okay, to store an integer. So I will call this my number, okay. If I set this to, for example, 8, right, and now for some reason my program needs double precision calculation, so I want to transform this int into a double, right? So I'll go and say double my double, right? And what I will set this will be to my number, right? So what I'm doing here is basically casting, or kind of automatic casting, this number, this integer, into a double, okay? So now we will print both results. So after here we're gonna say system dot.println, oh sorry, a system.out.println, and this parameter will pass my number, okay? And after we assign that into my double, you're gonna do the same. So you're gonna go system.out.println, and I'll pass my double, right? Okay, so now I'll open the terminal, I will compile the program, and I will run it. And as you can see, we have here, of course, these 6 remain from the previous tutorial. And this tutorial we have first our 8, and then 8.0. So we didn't have to do anything to transform this integer into a double. We just put it inside a double and it was transformed. So this is called automatic casting, right? So why does it happen? Well, because the integer is a smaller data type than a double, So, for example, an integer usually occupies 4 bytes and a double usually occupies 8 bytes. So there's no problem when storing something small in a big box, right? Because it doesn't matter that it is some empty space in the box, right? But what happens when the opposite happens, right? Imagine we have a byte, and I'll call it my byte, and I will set it to 9. And imagine I want to well, actually the opposite, right? So I want to put the number inside my byte. So the previous number was 8. So maybe we can go and say 800, right? And in the byte, what happens if I put my number here, right? If I put my number here, it's saying fit 4 bytes inside 1 byte, which is kind of strange, right? So we will see what happens when we try to print this to the console. So system.out.println my byte. Okay, so now that I want to print it, it says error. It doesn't even compile. So it says incompatible types, possible lossy conversion from int to byte, right? So what we have to do here is a manual cast. And we have to say get and try to fit the significant thing or the part that fits on the byte, and the rest is just discarded because there's no place to fit it, right? So to cast my number, we will put we'll open a parenthesis before it, and inside the parenthesis we will type the new type of this variable. In this case, it will be a byte, right? Okay, so now we will compile it again, and now it's compiled, as you can see, but now we will run it, and as you can see, it says 32. So why it says 32 if I'm putting 800? Well, because of the binary notation, right? So because of the binary notation, we're getting 32 and not the actual value we want. Okay, so now let's test with 80, for example. If int is 80, let's see what happens. And we still get the 80 here. Why? Because the byte is actually able to store an 80. So a byte is able to store values up to 127. So I will put the integer to 127, and it is still displayed. But what if I go one more? If I go to 128, right? So I'm going beyond the limits of a byte. And if I go beyond the limits of a byte, I can see that it basically goes to negative 128, because that's how negative numbers are represented here, right? So what happens if we go to 256, for example? Right, if we go and say 256 and we compile it, it says 0, right? Because it kind of doesn't fit it, and so we have this strange behavior, right? Which can be worked out, really, if you kind of do the math in paper. So this is how we cast into a different type of data type, right? So if the receiver data type is larger than the incoming data type, then it's an automatic cast. Otherwise, we have to make a manual cast, as we did here with casting these to bytes. So we're basically saying convert or transform this number to a byte, even if some information is lost in the process, right? So this is basically how we cast. We have already learned how operations work, right? So, which was really easy, basic operations. And we also used strings previously. So here, when we set the dog name, we are passing a string right here. So what is a string? Well, the string is a data type that holds text. if we want to define a string with a name, for example, let's say string my name, and I will open double quotes and I will type whatever I want. For example, Max, right? So if my name was Max, I will type Max or whatever my name is, right? So, and we can also use and get the string length, right? So how can we get the string length? Okay, so we will print the string length right here. For that, we're going to say system that, oops, so system that out that print ln, and what we'll pass will be my name. If we want to know how long is the string, we're going to say my name dot length, right? Which is an integer. We'll return an integer. And here, if we want to display more than one thing, we can concatenate two strings by writing double quotes. And for example, I will type my name length is, okay, and I'll put an addition sign to add the rest of it. So we now will compile the code and then run it. And as you can see, my name length is 3, right? Because Max has 3 letters, right? So very easy way to find the string, the length of string, right? So that's how we create and get the length of a string. And maybe we can also do some operations on strings, right? For example, we want to get some of the string, a part of it, right? So what if I want to get a part of it? So I'll type my name, which is the name of my string. Then I'll say that substring, which means create a substring. And if we tell it a begin index, it will cut everything that comes before that index. For example, if I pass the number 1, it will go to position 1, which is A. So remember, we start from 0. So position 0 will be M. Position 1 will be A, in this case, of Max. And we'll only print AX without M, because we're creating a new string by getting a part of the current string, right? So let's compile the code and run. And as you can see, only AX is printed. So that's it when we kind of want the last part of the string. But what if we want a middle part? For example, I'll say my, something larger. My name is Max, right? So if we want, for example, to get something in the middle, for example, name is something in the middle, and we will do the following. So M is 0, I is 1, the space is 2, N is 3. So we'll pass the first one, which is 3, and then a comma, and on the second one we will pass the end index. So in this case, it was 3, 4, 5, 6, 7, 8, 9. So you're gonna pass 9, and we will compile and run. And as you can see, it says name I. Oh, well, actually it's 10 here, right? So I counted wrong. So if I do it with 10, it says just name is. So what we're doing here is we're cutting the string and getting the part that is on the center in this case, right? So this is basically a cool string operation of how to make, how to get a substring, right? Okay, so there's also some math functions in the Java programming language, right? So let me delete these and create some math well, I won't delete the main method, so I will delete this method and I will delete the contents inside the main method. And inside the main method, we can find something kind of useful, which would be the math library. For example, the max value library. So, for example, if I call math, if I press dot, I can see all the methods I can call from math. As you can see, lots of mathematical functions right here. okay, which is great. Okay, but for example, the max library right here, it says max A and B. So as an A and B, I will pass 4 and 8, for example, right? So these will return basically the max number. So you can say int max equals max, okay? And then we will print the result or the value that's stored in max by saying system.out.print ln, and we'll pass the max. Okay, and now we will compile the code, and now we will run the code, and as you can see, it returns 8 because max is 8. So that's how max works. Pretty simple. Now the min function can also be used. You will say, but I can't tell. But sometimes procedurally, if you have a large algorithm, then this can become very useful. So now the min, which will return the minimum number, which is in this case 4. Okay, so pretty simple. So we can also get the square root of a number, right? So for example, if we want to get the square root of 8, I can use again the my library, and instead of min, I will say sqrt to get the square root of 8. And since the square root may be a double, I won't use an int right here, so I will use maybe a double, okay? And I will change from max to square root, okay? So I can print the square root right here, so square root, okay? If I compile this and run it, as you can see, here we have the square root of 8 with double precision, right? Which is 2.82 and so on, right? So that's a square root. What else do we have? Here? Okay. Let me see. So we have already learned a bit of math functions. These are kind of the most basic ones. Of course, you can have lots of more mathematical functions you can find in this library and in any other library. Now let's talk a bit about control flow, right? So control flow are the if statements basically. If we say if a condition is met, for example, square root is less than 3, then do something. Then print system.out.print ln, and for example we'll print square root is less than 3. So this is what we call control flow. If a condition is met, then do something, and else, which means if it's not met, then do something else. For example, in this case, system.out.print ln, that will print square root is not less than 3, right? So if we go here and compile the code and then run it, we can say that it says square root is less than 3 because it actually is. But what happens if we change here from 8 to 9? Okay, of course the square root of 9 is actually 3, so if we compile this and run, we say the square root is not less than 3, which is equal in this case, right? So this is how control flow works. But we can also do something else, like right here. Instead of else, we can also put else if. So we're checking if an additional condition is met. So if it's not less than 3, we will check if it's 3. So I can say if a square root equals 3, right? And if it equals 3, and we will say square root is 3, okay? And if this is not 3 and not less than 3, then it must be more than 3 or greater than 3, right? You can say system.out.print ln, okay, and we will say square root is greater than 3, okay? So if we go back and compile this, square root is 3, then it says square root is 3. Now if we go and put here an 8, for example, so the square root of 8 will be, the square root of 8 will be less than 3, so I'm going to compile it. So this is how we test that the program works. So it says square root is less than 3. Okay, and if I put 16, of course the square root of 16 is 4, so we'll check if that works. And it says square root is greater than 3. So this is basically how can we use this. We can say, we can use less than, greater than, equal, different, as I told you in one of the previous tutorials, right? So this is basically how the control flow operations work in the Java programming language. Now, instead of doing lots of ifs, we can do something differently, right? We can do something using switch, right? So you're gonna switch, for example, an integer, right? Or a double or something. So you're gonna type switch. So what switch does is kind of a lots of if and else if statement, right? So we will switch the variable. So the variable that we want to switch in this case is the square root variable. So we'll say square root, right? Okay, so we open brackets here, and inside these we will say case 1.0. Okay, so what does it mean? This means in case the square root is 1.0, we will do something, right? So we say case 1.0, we do something and then we will break. What break means? Well, basically means we're done it and we don't have to keep checking for something else. So then we're gonna, if it's not 1.0, we will check case 2.0, okay? And we will also break, right? And this is how we kind of do this. And we can also have the default case, which is, well, default, as the name says. So you just press default, and we have it. And we don't really have to break here, because default is the last element here. So that's it. So in the case it's 1.0, what you're gonna say is system.out.println, and I'll print it is 1.0, right? Okay, and in the case it's 2.0, I can say system.out.println, and I'll say it is 2.0, right? So, and in the default case, you're gonna say system.out.println, and we'll set this to default case, right? Whatever the case it is. Okay, so if we compile this program, we have an error right here from double to int. Okay, so what are we going here? Okay. So maybe we have to specify this to floats. Will that fix this? So let me check. Let me check. Okay. To make our lives easier, we will switch an integer, right? So here we're going to say int, and I'll say int to be switched. Anyway, the integer is the most common variable, right? So, and here we're going to say case 1 and case 2. We don't need these f's anymore. And we will say it is 1, and here we'll say it is 2. Okay, let's make this faster, right? Okay, if we go and compile this, and then we run it, so we have incompatible type, possible load. Oh, we don't have to switch square root, we have to switch int to be switched. Sorry, I forgot that. Okay, now, if I compile this, it compiles, and if I run it, it runs, and it says default case. Why it says default case? Well, because it is not 1 and it's not 0. So every number that is not 1 or 0, I mean, it's not 1 or 2, it will say default case. So if here I put the 1, okay, and I will compile the code and run it again, then it says it is 1. The same thing with the 2. If I put a 2 here, if I compile the code and I run the code again, it says it is 2. So this is how the switch statement works, which works very similarly that the if, else, and statements are also control flow operators that enables us to control the flow of the program, right? So that's it for control flows. Now let's maybe introduce you to while loops, okay? So which are the most basic loops we can make? Okay, so let me delete this to clean it a bit more. And to create a while loop, we just type while. Okay, while we open parentheses and then we open brackets. And inside these parentheses, what we will do is we will check for an state. Okay, for example, I will say integer loop count. I will set it to 0, and I will say while loop count is less than 10. Okay, then we will print. So I'm gonna say system that out that print ln, and we will print loop count. Okay, and we have to update the loop count variable. So we're gonna say loop count plus plus. So now let me explain what is this doing. Well, first of all, it is checking that loop count stays below 0, and while loop count stays below 0, we will print the current loop count. So it will print 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then these will increase the 9 to 10, and here we will check that 10 is not less than 10, and the while loop will end, right? And we'll stop printing anything else, right? So if we compile the code and we run the code, we can see exactly what I told you. So it prints 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? Because it is printing everything that is less than 10, okay? So it says everything that is less than 10, what to do? Well, print it, okay? So this is the most basic and most simple while loop. We also have the do while loop. So what's the do while loop? So let me delete this while loop. The do while loop is as follows. We can say do, we will open brackets, and after we end the brackets, we say while loop count is less than 10, right? So how is this different from the previous while loop? Well, the do while loop is kind of different. It's kind of a variant of the while loop. Okay, so this loop will execute this code and once, and then we'll check for the condition. Okay, so in the previous one, it first was checking the condition and then executing the code if the condition was met. So here it will execute the code at least once, right? Even if the condition is or not met, and for the next conditions, it will check if the condition is true, then do it again, right? So basically, I will print it again to see how it differs from the previous loop. Let's say system.out print ln, print line, I will print loop count. Okay. Okay, so if I compile this and I run it, oh, we forgot to update. So it's printing zeros because we haven't updated the loop count. So we're gonna say loop count plus plus. So we have to update it, right? So now that we have updated it, I'll run, and as you can see, we have the same. But how is this different? Well, because it will print the first one even if loop count is not less than 0. It's not less than 10. For example, if I set loop count to 100, and if I compile the code and I run it, it will still print 100, right? Because it will print regardless of the condition for the first time. Then it will check the condition and will print again only if the condition is met. So this is do while loop, right? Great, so this is also kind of very used. Now we will introduce the for loop, which will be the last loop we will learn. So how does a for loop works? Well, a for loop is more elegant maybe. We don't need an external variable. We can create a counter inside the for loop. How can we do it? Well, we say for. We open parentheses and we write int I equals 0. So I'm defining the variable, the counter, which was the previously loop count. So for convenience, I can also call this loop count if you want. So loop count 0, and I then type a semicolon. Then I'll check the conditions. I'll say loop count less than 10, and another semicolon, and I'll say loop count plus plus. Oops, loop count plus plus. So as you can see, it is way more elegant than the previous way, right? So it is way more elegant. So the first thing we define is the first statement, then the second statement, and then the third statement, right? So basically that is how this works. So now let's print it right here. I'm gonna say system.out.println, and I will print loop count. Okay, so if I go and compile the code, I can see that I am printing the loop count, right? Which is awesome. So this is the recommended way, or the most used way, because it's self-explanatory. But again, it depends really on the use case you need. So that is the for loop, and the last thing we will learn, the last loop, is a variation of the for loop, which is called a for each loop. Okay, for example, this works maybe when we have an array. So I'm gonna call it char array, my array. Now set this to new array, new char. So we're creating a new char array, and here I specify the size, for example, 10 characters, right? And here I will say for. Okay, so this is why this is called for each. So I'll say for each element of this array, do something. Okay. For example, if instead of defining these, we can also, so this is a way of defining the array. We can also define it manually by open brackets, like saying first character will be A, the second will be B, second will be B, and the third will be C, right? So that's how we define an array manually. So the for each will be for char I, for example, and then we press colon, and we say my array, okay, and we will do something. We will print system.out.println, okay, and we will print I, right? Okay, what is this saying is print every character on my array. Okay, so if we compile this and run it, it says A, B, C. So we have learned while loops, do while, for loops, and for each loops, and that's basically about the loops. So that's it for this video. I hope you enjoyed it, and I see you in the next one. Bye. Hello and welcome to part 4 of the Java course. So in this tutorial, we will keep learning more Java related features, and this time we will start with the break feature. Okay, so we already know how to break in a switch statement, but now we can also break inside a loop, for example, a while loop. So if we create a while loop, so we have to create an external variable. In this case, we will call it loop count, set it to 0, and inside this while loop, I will, for example, say while loop count is less than 10, okay, and I will here update loop count variable, saying loop count plus plus, okay, and here what I'll do is I will, for example, print the loop count. To print, we use system dot out dot print ln, and we will print loop count, right? So, but now how can we use the break statement? For example, we can use it in the following way. Maybe we don't want to end the loop. We want to check for whatever reason if the loop count is equal to 5 and we want to stop the loop. So we want to go outside the loop, okay? So kind of exit the loop before it has been finished, right? So to exit, we just call break, okay? So this means when the loop count equals 5, it will break the while loop, so it will continue here. So the break will continue here, right? So let's now run. Let me see. Let's compile the code and let's run the code. Let's say Java code. Okay, and as you can see, it doesn't print on to 10, but only till reaches 5, right? So this is what the break statement is doing right there, right? So that's break, but we also have the continue statement. Actually, it can continue the iteration, kind of force the next iteration. To see this, to figure this out better, we will put this if check before we print out the system, right? And what we will do here, instead of saying break, we will say continue. Okay, so when loop count is equal to 5, we will continue. That means that it will skip this code and will go to the next instruction, right? So let's see if we can do this, right? So let me check. We're compiling it, we're running it, and as you can see, it goes from 0 to 4, right? But the problem here is that it stops there because we are not updating this right here. So before doing continue, what we will do is will be loop count plus plus, and then we will say continue, right? Okay, so now we will exit the program by pressing Ctrl C, and we will compile it again and run it again. And as you can see, what it does, it prints every number, but it doesn't print the number 5, because when it reaches the 5 state, we're continuing to the next one, which is 6. So we skip the 5, okay, and we go into the 6th one. So that's how continue works. So we have learned how break and continue works, right? Now let's learn a bit about arrays, right? So let me delete this right here and continue with arrays. So an array is a data type that stores multiple objects of the same type. For example, if I want to create a string array, I will put a string followed by square brackets, and maybe I want to define colors, right? So if I want to define colors, I open a bracket and I can define it as, for example, red, green, okay, green, what else? Orange and black, for example, right? So this is how, and of course end it with a semicolon. So this is how we define an array. So the colors variable stores 4 items right here. And if we want to access one item of the array, we use what is called an index. So in computer science, we start counting from 0. So red would be at the index 0, green would be at the index 1, orange would be at the index 2, and black will be at index 3, right? So let's see if we can print this. So we're going to say system.out.println, and what we will do is we want to print colors at index 0, right? So if I print colors at index 0 and I compile the code and I run it, you can see that red is printed to the screen, right? If I go here and if I go to index 1, which is the second item, green will be printed, right? So we compile it, we run it, and as you can see, green is now printed. So this is basically how we can create strings instead of a string arrays, right? We can also, if we don't want to create an array of strings, we can create an array of integers too. So we're going to say int array, and we will define it as ages, for example, right? And we will define it again. So maybe one person has 10 years, another has 80 years, another 39, another 48, and so on. So the same things, if we want to print this again, we will say system.out.println, and we will pass, in this case, ages at 0, which will be 10, because 10 is the element 0, right? The first element. So if we go and compile the code, and then we run it, as you can see, the 10 element is printed to the screen. So you can have really any kind of object type on an array, right? So we can also maybe change an element inside an array, right? So to change an element inside an array, we can do the following. For example, we want to change the first element in ages. So we're going to say ages at 0, we will set it to 12. Okay, so instead of 10, I am writing 12 to the 0th element of the array, right? So if I print it, so let me compile it and run, 12 will be printed instead of 10, because now it doesn't have the 10 value, but it has the 12 value, right? So this is basically how can we do this. And we can also print the array length by calling, for example, ages.length, which will return the amount of items we have. In this case, we have 4, right? So 1, 2, 3, and 4. And if we print this, so let's check if this works. So let me compile. And here we have, it says cannot find symbol, and it says variable length. Oh, okay. So this means that this length is variable. To have a fixed length, we have to define it here, for example, int, and say 4, right? And we have 4 items, right? So I think that would be the fix right here. Okay, let's see if that's the case. Okay. So I don't think that will fix it. So let me see right here. So maybe this length thing says length cannot be resolved or is not a field, which is kind of strange. Maybe because this is not final, maybe? I don't really know. So this is kind of strange to me, because it should print the length of the array. Maybe it doesn't work with integers array, so let's try it with the colors, right? So colors.length. Okay. Oops, I'm writing length wrong. Colors.length, right? So I think it was a typo actually. Oh, it says 4. So I think I have a typo here. So let's go and say ages.length. And yeah, it definitely was a typo. So I, instead of ending with th, I ended with ht, which was my error, right? So that was a quick to fix error. So as you can see, in both cases we have 4 elements. So here we have 4 and here we have 4. So this is how we can access an array in Java. Now, what if we want to change all the elements of the array? Or maybe we want to print all of the elements in colors, right? So we will use a loop that will enable us to do that. So for example, the simplest loop, or the more convenient in this case, will be the for loop. We're going to say for, and I'll say int I equals 0, I less than colors that length. Okay, I less than colors that length. Okay, is this correct? Let me check. Length, apparently it is, and we will say I plus plus. Okay, and inside this for loop we will print the colors, right? So this basically means print the colors, all the colors, right? But here, instead of using the index 1, we will use the index I, because we will be increasing the index y, and it will print 0th element, then the 1th, the second, the third, and so on. And if we compile and run, you can see how it prints red, green, orange, black. So this is how we can access array elements using a for loop, right? So this is basically how arrays work, which are very, very useful. We can have byte arrays and so on. So now what we will learn will be exceptions. So an exception means that when an error occurs, we have an error message, right? So that event in which the programming language kind of throws an error message is known as an exception, right? So let's try to force an exception and to generate one. Okay, so let me delete this, and inside the main method I'll type the following. For example, I want to create a Boolean array, right? It can be any kind of array, maybe. So Boolean array, and I will call it my Boolean array, right? And I will set this to brackets. I'll set it to true, then false, and then true, right? So there is my Boolean array, right? Which has 3 elements, by the way. Well, the first one is true, the second one is false, and the third one is true. So what happens if I want to print an element that doesn't exist? So I say system.out.println, okay, and I'll print the thing at my Boolean array, but at element 5, for example, which we don't have a 5, right? We only have at most 3 elements, right? So when I will try to run this now, okay, so I will compile this, and now I will run it, and as you can see, we have exception in thread main, okay, Java lang array index out of bounds exception, index 5 out of bounds for length 3. So this means you're trying to access element 5 on an array that only has 3 elements. So this is what we refer to as an exception, okay? The event that throws an error, right? Now, when an error occurs, maybe we don't want this to be thrown, but we want to catch it. So to do that, we will do the following. So we will surround this code with the try and catch blocks, right? So we will do the following and manage an exception, right? So we're going to say try, and we will open a try, and when we finish this, we'll say catch. We'll open parentheses. Out here we will write exception and the name of exception. In this case, I will call X maybe. Okay. So I'll put these two lines inside the try block, which basically means try to do this. And if it's not possible for some reason, catch an exception, right? And when we catch an exception, we want to tell the system that we have catched the exception. So you can say system.out that print ln, and here we're gonna say like something went wrong, right? So we want to tell that something went wrong, right? So we have an exception. Okay, so if we run this, as you can see, it prints something went wrong. Okay, so this is how we catch and handle an exception, right? Okay. So we are also able to execute some code after we catch an exception, right? So to do that, we use the finally feature. So after catch, we type finally, we open brackets, and what we'll do here will be print something. So we will system.out.println, and we will print something like this is the finally block, right? In your real world application, you may want to do some clever stuff here, some stuff that you actually need to do, but since we're just testing, we're just displaying this is the finally block. So if we compile the program and then run, here we can say that this is the finally block. So this will be executed regardless if the session was catched or not, okay, if the exception occurred or not, right? Otherwise, the catch will be only executed when the exception occurred, right? So this is basically how exceptions work in Java. So they are kind of very useful in real world because we can have null pointer exception, which means we're trying to access an element that is null or hasn't been initialized or has been freed from memory and so on, right? So this is basically how we can catch an exception, right? So now let's try to learn a bit about methods, okay? So maybe we want to create a method with parameters in that we want to access them. For example, if I create a method that I'll call void my method, okay, and we open parentheses, and inside here what we write here will be called parameters. It can be any data type you want, for example an integer, and for example it would be a number. Okay, if we open this, we can also have more than one parameter. We can have a string right here, so I will call it my string. Okay, so when we pass and when we call that method, so from the main method I will say my method, okay, and it will tell me that I cannot, let me see, my method, and I will pass 0 as the first one because the first one is an int. So the data type I've passed I have to pass it in the same order that I have defined up here. And the second one is a string, so I have to pass in a string like hello, right? So that's how we define my method. Now, if we try to compile this, what will happen is that it says Java and here we have the line in which the error is located. It says error, non-static method, my method cannot be referenced from a static context. So what does this mean? It means that if you are inside a static method, as in this case, we must call also static methods only. So we're gonna make this method static, and now if we compile it, it will actually work, right? So that's basically how we have to do that. So that's basically about methods. We can pass not only these, we maybe want to pass a string array or an integer array, or maybe we have even custom objects we created, right? Like a dog, right? We can even pass a dog, like a dog class, right? So that's basically how we pass methods between function calls. Okay? Okay, so if we go back to the dog class and we kind of rethink about it, now that we know a bit more about how classes works, a bit more how parameters work, now we have these two constructor methods, which means that they build the object, right? That's why they are called constructors. Okay, so these constructor methods are called depending on which parameters you pass, as I explained in one of the previous videos. So this Java language is very interconnected, so we have to go back and forth between concepts to actually understand what we're talking about, right? Okay, so here if I call dog without any parameter, it will create a dog, but without any parameter. But here, when I call it with a name, I want to set the name of the dog, right? So I want to set the name of the dog, but we don't have a name field, so we will create a name field. So you can say string name, okay? And as I told you previously, when I call the dog thing, we want to set the name. To access the name that is outside these methods, so we want to access this name right here instead of this one right here, we use actually the word this. So you can say this that name. What I'm telling it is access the name right here, and I'll set this to name. Okay, so let's try to check if that even works. So we will go and delete this method, and what I will do is I will call the dog class. So you can say dog, my dog. Okay, now set it to new dog, and I will pass a parameter because I want this to be created with a name. I'll pass max again, like a name. Okay. Okay, so max 1, for example. So if we try to compile this and run it, we can see how it works. And now we're gonna print out this. Gonna say system dot out dot print ln. We'll set this to print the dog name. So I'll say my dog dot name. Okay, so if we do this, we're gonna go ahead and it will print max 1. So that's how we can do that, but that's basically the modifier that enables us to do that, okay? But what if we don't want the outside world to access this? Okay, so maybe we want to call this make it a private value. So if I make it a private value, when I compile it, it will says Java at line 6, it will says error, name has private access in dog, okay? Which means that the name string right here can only be accessed from inside the dog method, okay? So we cannot access from outside it. But even when we have this, we can get the dog name. How? Well, in the following way, we can create a public string get name, okay, and this will return the name of the dog. So I'm gonna say return name, and this can actually access name because this method is located inside the class. So I cannot do dog.name, but what I can do my dog.get name, okay? So I can actually do that, right? So if I compile this and run it, now we can access max1 even though name is a private modifier, but we are using a public method that returns a private to this class object, which is the dog name, right? So this is how we basically use this. So sometimes we see that methods are static, like the main method, right? So what does it mean, okay? Well, it can mean that the method can be accessed without creating an object of the class, okay? So how can we explain this better? Okay, let's do an example, right? And let's create a static and a non-static method inside the dog class. So we already have some non-static methods, right? Like the get name or get age or whatever, right? But what if we want to create a static method? For example, a static void. I'll call it my static method, right? If I open this method, okay, and I will do the following, right? I will say system.out.println, and I'll print this is my static method, right? So basically I'm trying to illustrate the difference between static and public, for example, right? So we have here a public one and static method as I am selecting them, right? But if I call them from main, for example, or even from another method from the constructor, maybe right here, I can call both methods from here. And what this means is that let me see. So we can call the static method without creating a class. You know, we can call the static method without creating a class. Whereas if we call the public method, we cannot call the public method without creating a class. So let me illustrate this even better, right? So inside, when we create this dog, I will call my static method, right? I will just call my static method when I create the dog, right? Okay, so if I call it, yes, I'm actually calling it. So let's run it. Let's compile and run. It says this is my static method, which worked, right? But what if I want to call my public method, like for example, get age, right? So if I call get age, okay, I compile this, oops, and I run it, then, okay, let me see what happens here. So in the public method, I will try to call this public method right here. So let me check. So the problem is that here we are already creating the new class, okay? So let's try to do the same but in the main method, right? So let's, outside the main method, I will create a public method. So say public void, I will call it my public method, right? Okay, I will open brackets on here and I'll say system.out. Okay, we're calling this, of course, from inside the main method, so I call it my public method. I'm gonna say system.out.println. Okay, and here I'll say I am public method, right? So this is our public method right here. And now inside the main function right here, which is a static method, and if we want to call a public method, like saying my public method, right? If we want to do this, and if we compile this, it will give us an error code that would say non-static method. But what I want to illustrate here is that we can we need to create a class before calling a static method, right? So we need to access an object of the class, right? Okay, so when we try to compile this, it will give a compile error, right? Whereas if I make this method static, I don't need to create a new class. I don't need to call a new class, right? So I can just call my public method and it will work right away. Oops, let me see. So it will compile and then it will work, right? And it will say I am a public method. But how can I call a public method? How can I do this? Well, I can still do this creating an object. So how can we do this? So if I call it right away, it won't work as you saw. But I can create a new class. It'll say, for example, Java code. Okay, Java code, and I'll call it my class. And I will set this to new Java code. So I'm creating a new class. So let me call this way. Okay, so we have new Java code, and right here I can go and say my class dot my public method, and now I can actually call the public method from inside the class. So if you want to call a public method, you want to create a new class, whereas if you want to call a static method, we don't need to create a new class. So this is kind of a very, very interesting concept, kind of new if you haven't used Java previously, but very important. So that's it for this video. I hope you enjoyed it, and I see you in the next one. Bye. Hello and welcome to part 5 of the Java programming language tutorial. Okay, so let's go and switch a bit topics. We want to learn about Java inheritance, right? What is a subclass and what's a superclass and so on, right? So in Java, it is possible to inherit the attributes from one class to another, right? So it can be either a subclass or a superclass, right? So a subclass is like a child of a class. So it is a class that inherits from another, right? And the superclass is the parent. So it's the class being inherited from, right? So to inherit from a class, we use the extends keyword, right? Okay. So maybe we want to inherit from the dog class, or maybe we want to create a new let's create a new example to kind of have a fresh content, concept here, right? So we delete the dog class. I will delete this public method too. Okay, I will delete this content that is inside this main method. Okay, and what I'll do here is I'll create a class outside this Java code class, and this class will be called vehicle, right? So vehicle. I will open brackets, and I will write protected string and maybe the vehicle brand, right? So brand, and we can set it this to brand X, for example, right? Okay, so this is an attribute, right? We can also create a method that will be public void accelerate, right? Because the vehicle is able to accelerate, right? Okay, so we have this method right here, and we will here output something to the screen, like saying system.out.println, and what I'll pass to this method will be accelerating. Alright, so this is our accelerate method. Okay, so this vehicle has a brand which is brand X, and also has an accelerate method, right? Now, if I want to create a car class that will extend or inherit from vehicle, right? So I'm gonna say class small car, for example, right? So you can say small car, and then I will type extends vehicle, right? So this is how we can extend a class, and right now we can change and maybe create something else, a new attribute, for example a model, right? So we will create it as a private to better picture this. So again, private string, and we say model name, okay, and we'll set it to model X, for example, right? Or model Y, for instance, doesn't really matter, right? Okay, so we have our model name, private string, and if we can now also create a main method inside this class, right? So if we create a main method, what it'll do will be the following. So the same main method that we used in Java code, right? So if we want, we can create a new class, or we can also use Java code itself to extend the vehicle class, right? So I'm gonna say here extend vehicle. It will also work right here. So any class can extend another. So vehicle, but it can only extend one, right? So extends vehicle, and it can, again, I can put a model name right here, and now it inherits all the properties of vehicle, like the brand and the accelerate feature, okay, and maybe add something new, which is a model name in these two classes. So this is to illustrate that these both classes can inherit from vehicle, right? So that's basically how we did this, okay? And now here what we can do is the following. Inside this Java code class right here, I can create the following. So I can say Java code, I will call it my car, because it is extending car, okay, and I will put new Java code, right? Okay, and now I can say I have to call the Java code method, right? So I have to call it, and now I can say my car dot accelerate. So do you understand what's going on here? So I'm extending the properties of vehicle, right? That's why I can accelerate from here, right? So this is basically how we can access this class, right? So if we want, sometimes we might want to make this method static if we want to, right? Sometimes that may be handy to make the method static, or maybe we don't want to make the method static, right? So let's see what's going on here. Okay, let's say new car, class car extends vehicle, we have our vehicle class. Okay, now we will run this to see if it works or not. So it says identifier expected. So apparently we need something else right here. Let me see what's going on here. If we call my car and we call accelerate, then we have to call this from the main method, right? Because that's where all this code is executed, right? So we call my car accelerate from inside the main method, right? That's basically how we do this. Okay. So it says cannot make a static reference to a non-static field, right? So maybe we cannot make this static, this accelerate method, right? So now, we still have this. We have to, sorry. We have to put this my car thing inside the main method, right? So in this way, we're creating a new class and we can access its method, right? So now, if we go and compile the code, okay, as you can see, it says accelerating. So this is calling my car, which is Java code, which is extending vehicle, which is actually printing accelerating, right? So this is basically how inheritance works in Java. So sometimes this is useful to reuse a previous code. So if we want to create a car, but we don't want to rewrite these features, we can reuse the vehicle features and add new ones. For example, in this case, a model name or something like that, right? So this is basically how inheritance works in Java. Okay, so, well, that's it for inheritance. Now we have to as we know, we can put two classes in one same file, as we have been doing it in this tutorial and in some previous tutorials, right? But what we can also do is create a class inside another class. So in theory, what I can do is I can create a class inside this vehicle class. So for example, I would say private class I am inner class. So this is an inner class which will be created inside the kind of a larger class. Okay, so this is basically how we perform. So we don't have to call a method because it's a class, so remember that. So it says private class and I am inner class, and inside here we can do whatever the case may be, like any other class. So that is kind of the introduction to an inner class. Now this inner class can be private, can be static, can be public, can be protected, or whatever the case may be, right? So this is basically how an inner class works in Java. Okay. So what else do we have to learn about Java? Okay, we can learn enums or something like that. I don't really know how to pronounce it correctly. But enums are kind of useful sometimes, right? I don't use them very often though, but for some applications may be useful. So right now I will delete these two classes we just created, right? We will delete the my car that accelerate call, we will delete these, and we won't extend vehicle because we don't have that class anymore, right? So now we have our public class and our main method, which is all we need for now. So an enum is a class that represents a group of constants, okay? So variables that don't change. Okay, so to create an enum, we will do it in the following way, right? So we will basically do the following. So let's say enum, and I want to call it state or something. And if I open this, I can maybe define these as state 1, comma, state 2, comma, state, okay, let me see, so, comma, state 3, right? So this is an enum, right, in which we have an state, and inside it we have different states, right? So basically, we should put this outside the main method, right? So we should put it right here. Okay, so that's better, and that's how we define an enum, right? So to access an enum, we can do it in the following way. For example, if I say state, which is the type of the enum, we'll say state my state, for example, and we will set this to state that state 1, right? So as you can see, I'm creating a new state, which is a new type I created here with an enum, and it has different possible enumerations of objects inside it. And I'm assigning this my state, so it's a state, to one of those possible values, right? Which in this case, I'm assigning it to state 1. So sometimes this can be useful to define variables that have different possible states or objects encapsulation, okay? So that's basically how we work with state, okay? With enums, actually. So now we will delete this and we will learn about how can we get input from the user, right? So to get input from the user, we will import a library. So to use some stuff, we sometimes have to import something. To import something, we go kind of to the first line of the file, or just before the public class is defined, and we say import. In this case, we will import the Java.util.scanner, right? So we're importing this class, and we will use it accordingly. Okay, so inside the main method right here, we will create a scanner. So it will be a scanner. I will call it my scanner, right? And I will set this to new scanner. Okay, and I want to scan the keyboard, right? So I will say system in, right? And that's how we basically create a scanner, right? Now, if I want to tell the user to enter something, I'll say, for example, system.out.println, and I'll set this to enter something, right? To write something, if you want to do it that way. So I'm going to say write something, okay? Of course, we have to end the line with a semicolon. And after these, we will go and get what the user kind of entered, right? So to read the user input, we're going to store that in a string. So we're going to create a string. I will call it something because we're asking for something, okay? And what we'll do here will be my scanner dot next line. So get the current line, get the next line of the user input, basically, right? And now if we want to output what the user entered, we're gonna say system.out.println, and what we will output in this case will be you entered, and we will tell the user what he or she just entered, in this case something, right? So let's now check if this actually works. So we will compile it and run it, and it says write something. I will write hello, how are you? Okay, now press enter, and it says you entered hello, how are you? Okay, so basically we now know how to get input from the user, right? We can use these to check something. For example, I would say if something that equals I don't know, maybe hello, okay, and we will say system.out.println, and if the user enters hello, we will answer hi, how are you? Okay, so with the equals feature right here, we can check if a string is the same as another string, right? So we will do just that. So we compile the code, we run the code, and I will write hello, and it says you entered hello, and it says hi, how are you? Of course, this hi, how are you will happen only if I enter hello. If I enter hi, it just will say you entered hi, but it won't say hi, how are you, right? Because we told the computer to just do it when we enter hello, right? So this is how can we can get input from the user. Here we are calling next line, but if we want to get an integer, we'll maybe call next int, or next long, next short, next double. Of course, we have to start and accordingly right here instead of string, right? So this is how we enter or ask the user or get the user input, right? So pretty easy, right? So now let's learn how we can get the current date in Java, right? So to get the current date, we will do the following. First, we will import java.time.local date, right? I don't know if my computer has the current date, but we will find out, right? Okay, so I will delete all of these we created previously because we don't need it anymore. And what I'll do now is the following. I'll say local date, and I will call it my date. And I'll set this to local date.now, okay, which is basically telling us the now date, right? So now that we have this, we can do the following. We can say system.out.println, which means print line, by the way, and what we'll print will be my date, okay? So now we will compile the program and we will run it, and as you can see, this is the current day, which I think is okay. Yeah, I think it is okay. So that's basically how we can display the current date. Now, what if we want to display the current time? Okay, for that, as you may guess it, we have to import java.time.local time, right? And right here, we will do the same, but we will do it with a local time. So we will say local time, and I will call it my time, okay, and I'll set this to local time dot now again. So pretty much the same as previously, right? And now I will print that by saying system dot out dot println, and I'll print my time. Okay. Okay, sorry, it's a typo here. And now I will compile this and I will run it. And as you can see here, we have the time, which is a very precise time, right? Because we have the current hour, minutes, seconds, and milliseconds or nanoseconds or whatever the case may be, right? So we have a very precise time, okay? So which is great. Okay, so that's how we can print the current time in Java. But if we want to format it in some way, we maybe want to show the day first, then the month, and then the year, or something like that. So how can we do that? Okay, it's actually not that difficult. So if we want to, so there's a function that actually prints both of them, both of these, right? So we will use that function. So, okay, so we don't need these other imports, and what we will import is the following. So we will import java.time.local date time, okay, and we will also import the following. We'll import java.time.format.date time formatter, right? So that will enable us to specify the format we want for our time. So you're gonna do something very similar we did previously. We'll do local date time, and we'll set these to my time, okay, and I'll set this to local date time that now, okay. So that's here. Now I will print some stuff right here. So I will show you how this looks first before we format this. So system.out.println will be like something like my time, right? Okay, and then we will format it and print the new form again. So to format it, we need to do the following. We say date time formatter, okay, and we'll say my formatter, and I'll set these to assign this to date time formatter dot, and here we're gonna say of pattern. So now we will be able to define the pattern. So let me put this in a new line for better readability. Okay, so that of pattern, and we'll say, for example, if we want day, month, and year, we can say lowercase dd, and then minus uppercase mm, minus lowercase y, for example, right? And then if we want the hour, minutes, and seconds, we can say hh, colon, and mm, colon, and ss for second, right? So that's how we can define the format of our formatter, right? So by the way, you can put some content in one line and some content in another line. So that's very, very useful in Java. So now we're gonna say create a new string which will be the formatted time. So I will say my formatted time, okay, and I'll set these to my time that format, okay, and what I'll pass will be my formatter, okay. my formatter. Okay, awesome. So now the string has the formatted time. So I want, of course, to print that too. So I'm going to say system.out.println, and I'll pass my formatted time. Okay. So now that I've done this, what I'll do is compile the code. Oops, and I forgot something. So in line 11, we have some errors right here. Oh, we have to put this inside double quotes, so I forgot. So all this format will be put inside double quotes, right? So now let's compile it again. And now it's compiled, and let's run it again. And now we can see the first date without format, or kind of the default format if you want to call that way. And the second one very formatted and looks a lot nicer. So we can format it in very different ways, depending maybe on the country you're in or something like that. So this is kind of useful because maybe you want to save a file and the name of the file you want it to be like the current date. So this is very commonly used by camera applications. So if a camera is created, then it usually saves the photo as the time. So the photo file has as name the time of the photo, the time at that photo was taken, right? So that's very useful for us right now. So that's it for this video. I hope you enjoyed it, and I see you in the next one. Bye. Hello and welcome to part 6 of the Java programming language course. So in previous tutorial we learned how date works, as well as some other useful things about Java. In this new tutorial we will start with array lists. Okay, so an array list is a kind of resizable array, which basically enables us to use memory more efficiently. This means this will grow as we need more space, right? So that's basically the difference between an array and array list. To use an array list, we have to import the array list class. So you're gonna say import java.util.array list. Okay, great. Now that we have imported the array list class, what we have to do, we'll have to do the following. We will define an array list. To define an array list, we will type array list. In this case, let's define a list of strings, right? So I'm going to say string. And I will call these, for example, fruits or colors or whatever the case may be. Okay, let's call it fruits. Okay, and we will assign that to new array list. Okay, which will be set also to string, right? So new array list and to string, as you can see. So that's how we create a new array list. Now we can create it inside the main method or outside the main method, whatever we want to do it, right? So once that we have created this, we can add items to the array list. For example, we want to say fruit, and we will write that add, and I will add orange, right? Oops, orange, right? So I add an orange, and now it will only use the elements that I'm using here, okay? So as you can see, you have a warning from a non-static field, so this requires me to use the static field. To avoid that, we will try to put this inside the method. Okay, it still needs some, no, it doesn't need. Okay, so we add an orange right here. So we're just doing this for convenience, but you can still initialize it outside the main method as we learned in one of the previous tutorials, right? So we add orange, and now we will add something else. For example, fruit that add an apple. Okay, fruits that add. Okay, we can keep adding more and more fruits, like a banana or something. So we have 3 fruits so far, right? And if we want to print the array list, we can access an item, or actually print the whole array list if we want to, right? So for example, if I say system that out dot print ln, and I'll set this to fruit. Okay, so let's see what happens, right? So we go to our terminal and we will compile our file, and here we have an error right here that tells us that we have some sort of, oh, we have to call the array list method, right? So after we initialize the array list, we put 2 parentheses, and that's how we call the array list method. Okay, so let's compile it again, and now let's run it. And as you can see, it prints orange, apple, and banana, and does it using square brackets and commas to separate the elements, so we can know what elements we are using, right? So let me clear the terminal output. And now let's access an item. So what if I want to just print the first item? Okay, so to access an item, it's very simple. So let's go and print it. So I can say system that out that print ln, and what I'll print will be fruit. And to access an item, what I have to do is that get and pass the number of the item, for example 0, right? Which is the first item, because we start counting from 0, right? So let's now compile the file and let's run it, right? So, and as you can see, only the first item is being printed. So we can also remove items from here. Okay, so if we can remove an item, for example, we can say fruit dot, and to remove an item, we can do the following. We will call remove, and we will remove item 0, right? And after we remove that, we will print the array list again to check if it changed, if it has changed or not. So print ln, and we'll pass fruits, right? So now we'll go to our terminal, compile, terminal run, and as you can see, in the last line of output, we don't have the orange element because we have removed it. Okay, apart from removing the element, we can also change the element, right? We can set the element, okay? So for example, we will go and say remove. Instead of remove, we will set. So you can say set. We will specify the index, for example 0, and I will set the first element to another fruit, maybe grapes, right? Okay, I will set, of course I have to define these grapes inside double quotes because it is a string, right? So now we set the 0th element, or the first element in this case, to grapes. So if we go again, you can see orange, apple, banana, then we print the first one, then we change the first one to grapes. We change orange to grapes. So that's how we add, how we remove, and how we change an item. We can also know the size of an array list. To get the size of an array list, we'll do the following. So we will print system.out.print ln, and what we will do here will be fruits.size. Okay, and now let's compile and run, and it has an error right here. It says size has private access in array list. Oh, the problem here is that I forgot to call the method, so we have to put 2 parentheses after the size word. Okay, and we will do it again, and now it works. So size is 3 because we have 3 elements. Okay, also we can clear an array list. You know, to clear an array list, we just say fruits.clear, if I'm not wrong, right? We say fruits.clear, and we will check if it works or not. Oops, but I have to print the results, right? So we're going to say system.out.print ln, and I'll print fruits. Okay, so let's compile the code and let's run it again. And as you can see, it just appears an empty array list because I have cleared all the elements. Sometimes this clear is useful because you don't want to keep using the same elements, so we just clear them, right? So that's the way we can use an array list. Now, if we want to create elements in a programmatic way, we can do so too. For example, we can create a for loop. So let's say for int I equals 0, okay, I less than 100 if we want to create lots of elements, and I'll say I plus plus, right? So inside this for loop, what I will do will be the following. Will be fruits.add, and I will add the current element, which is I. The problem here is that we are sending an integer to an array that contains strings. So we want to transform this into a string, right? So to transform this into a string, we will say string.value of, right? And we will enclose I in parentheses, okay? Oh, the O in of is uppercase, right? So now we will compile the code, we will run the code, and I know we haven't printed again, so I almost forgot to print the new state of the array list. So I'm going to say system.out.print ln, and I'll say fruits, right? So I'm compiling the code, I'm running the code, and as you can see, we have all the elements right here. But we don't have the fruits because we have cleared it, right? So what happens if we don't clear it? So let's comment this clear line, right? And let's run it again. Oops, what I just did. So let me compile this. Okay, and as you can see, we have the last output is grapes, apple, banana, and all the numbers we have printed, right? So this basically gives you an idea on how an array list works, right? Pretty easy, right? So this is very, very useful to avoid using memory that we don't need, right? So that's basically how an array list works. Now, what else can we learn about the Java programming language? Well, we have learned basically all of the most important things. Of course, there's stuff that we haven't learned, but that's maybe kind of advanced stuff. So something that will also be useful for us will be the ability to open files or manage files somehow. So let's learn it right now. So again, you can keep all this code, but I will clear this code in order for us to better visualize what I'm doing, right? So let's go and try to use and learn about Java files, okay? So to use files, we will import the file library. So you're going to say import, and we will import java.io.file, right? So this is how we import the file library. And inside the main method, we will create a new file. In this case, we call file. I will call it my file. Okay, and I'll set this to new file. And maybe here I will put the file name I want to create. In this case, I will call it my file.txt, right? But because this is a string, I have to write it between double quotes, right? So my file.txt, so that's the name of the file I want to manage, create, write, or read, or whatever the case may be, right? So here we can read a file, write a file, delete a file, rename a file, do many stuff here, okay? So what can we do here is, first of all, check if the file exists or not. So we're going to say if my file that exists, okay, if it exists, we will say we will print system.out.println, and I will print the file exists, right? And if the file doesn't exist, I will print system.out.println, and I'll print the file does not exist, right? So now let's compile this program and let's run it, and it says the file does not exist, right? So what happens if we make a file? So if the file doesn't exist, we will make it. You know, we will kind of create that file, right? So we're gonna say my file that create new file, right? So we will do this, and let me check if we are using this correctly. I think it is being used correctly, but somehow we have a warning right here. Oh, it's saying us that it throws an IO exception. So if we click here and surround with try catch, we can see how this is fixed. So it creates a catch block, and then it catches the exception, right? So we have learned already how exceptions work, so this is just a reminder for us, right? So now we will, after we do this, we will check again if the file exists or not. So after we create a file, we will check again. So I'm going to say if my file that exists, I will do system.out.println, and what I'll print will be the file was created. Okay, so exist is a method, so I have to call it as I am calling a method. And okay, this file doesn't exist, we will put this before we create a file. So we will say file doesn't exist, then we will create a file, and if it succeeds creating the file, we will say the file was created. And if for somehow it doesn't succeed, for some reason it doesn't succeed, we will say system.out. Okay, let me check, system.out.println, and what I'll say, the file couldn't be created, right? So now we will compile the program, and now we will run it. And first it says the file does not exist, and then it says the file was created. So if we go back here in the Visual Studio Code, we can see actually the file we created, which is an empty file, right? So we have created a file right now. So that's awesome. We can also delete a file, right? So we will set the file exists, and then we will delete the file, okay? So we're going to say my file that delete, right? And after we do this, we're gonna say file was deleted, right? System.out.println, and it will say file was deleted. Okay, so if the file exists, we will delete it automatically, right? So let's compile this and let's run it, and it says the file exists, and then it says file was deleted. And as you can see, it was actually deleted because we don't have it here, right? And now if the file doesn't exist, in this case, we create a file, and if it exists, we delete the file, right? So this is kind of the logic we're using right here. Okay, pretty easy. But now maybe we want to rename the file. So instead of deleting the file, we want to rename the file. So we're gonna go and say my file, and what we will do here will be that rename, if I'm not wrong. So let me check this. My file 2.txt. I don't remember really if it's rename or rename to, I think it is. So rename to. Okay, let's check if that even works. As you can see, incompatible types, a string cannot be converted to file. Oh, okay. The issue here is the following, that we have to pass a file here. So to rename to my file 2.txt, we have to say new file. Okay, and inside these we will pass my file 2.txt, right? So basically what this is doing is creating a new file and renaming it to it, basically, right? So if the file exists, we rename the file. So, and we will say system.out.println, and we will say the file was renamed, right? So let's compile the code and let's run it. And as you can see, it says the file doesn't exist, the file was created, which is exactly what we expect. And here we have my file.txt, okay? But now if we run the same program again, it says the file exists and the file was renamed. If we check right here, we can see that the file was actually renamed to my file 2. So that is how we can manage a file. But now, what if we want to read a file, right? So if we want to read a file that was already created, so let me open this my file 2.txt, and I will write something here. Hello, I am a file, right? And I will save it and I will close it. And now I want to rename the file. Okay, so I will only say the file exists, right? But I want to read this file and get the contents of this file. So if the file exists, I will read it, right? So to read it, I will do the following. So we will import again the scanner library, which we use to get input from the user. So we can also use that to get file content. So we're going to say import java.util.scanner, right? So that's kind of the class we need. Okay, then we're going to go here, and after we say the file exists, we're going to say scanner. I will call this my scanner, and I'll set these to new scanner. And what I'll do here is I will pass the file right here, which is my file, right? So I want to scan this file. I want to get the contents of this file, right? So this warning appears again, and it's telling me basically to catch the exception. So I will catch the exception right here, and something went wrong. Let me check what it was. So yeah, here we have the scanner and the catch and try it and catch block, right? So we create this scanner, and what we do here is we will check how many lines it has, and if it has more text to read, we will keep reading it, right? Okay, so we'll do in the following way. We're going to say a string, and we'll call this string data, and here we will set to my reader that my scanner actually, sorry. So it's my scanner that next line. Okay, that next line. Okay, so this will get the next line, but I want to first check if it has a next line before doing it. So I'm gonna say while, okay, while my scanner that has next line, okay, and this is mito, so I call it. So while scanner has next line, I will put this inside that. So I will say string data my scanner dot next line. So we store in this string variable, we store one line of the text, and after we store it, we're gonna put that out to the system. So you're gonna say system dot out dot print ln, and what we will print will be data. So after we say the file exists, we're gonna say system.out.println, and we will say the file contents are, and we will print the file contents, right? So after we've ended doing this, so after the try and catch block, what we will do here is we will close our scanner. So because we don't need it anymore. So you can say my scanner, which is not accessible here, so I will create it outside this maybe. So let me try to check it if that's possible. So before you try, I will say scanner, and here I'm gonna say my scanner, right? I just define this here and I assign it inside the try block. And after the try block, I say my scanner dot close, which basically tells the system that we are done using this scanner, and the system can now just close it, right? So that's basically how we can do this. So now let's run it to check if it works. So remember, we have this my file 2, okay? So we will also have to read my file 2 here, okay? So inside this my file 2, we have only one line. And let me switch back to the code. If I open the terminal, I'm gonna go and say compile the code, run the oops, we have a sort of error. I have forgot to put a semicolon in this line, so never forget to do that in Java because it will cause errors. So we're gonna say javac javacode.java to compile it, and we have another one, might have not been initialized. So what he's telling me here is that he doesn't, the language doesn't know if I have initialized the scanner previously, right? So maybe it will cause a null pointer exception. So I can maybe check here and say if my scanner is different than null, okay, I will say my scanner dot close, right? So this is just to illustrate basically, okay? So you're gonna say compile, and it has not been initialized. Okay. So we have to close this inside the try block, okay? So we have to close this inside the try block. So we'll move this after the while loop. So make sure it's after the while loop. And yeah, that will fix this. Okay, so as you can see, it's fixed. And if I run, it says the file contents are hello, I am a file, right? So that's how we read a file. So to check if it is able to read more than one line, so hello, I am line 2, and I'll say hello, I am line 3, right? So if I go back here, I compile it again. I don't really have to, but well, I run it again, and here we have hello, I am file, then it says hello, I am line 2, and then it says hello, I am line 3. So remember, we are printing the lines as long as the scanner has a next line. So in this case, it has 3 lines, so it prints these 3 lines. So all the lines that it finds on the file will be printed, right? So that's basically how to use files in Java. So far we have used learned the basics of Java and the most important thing. So 95% of the time you will use all that we've learned in this Java course. And sometimes you will maybe need something else, but that is really advanced. So this is kind of a beginner course, an introductory course. So that's why we're covering the most basic and useful features about the Java language. Which, by the way, as I told you in one of the early tutorials, Java is able to run on any machine. So Java runs in what's called a Java virtual machine. So this program right here, you can run it on Linux, on Windows, on Mac, on Android, on any platform that has a Java virtual machine. So basically anywhere. And that's why Java is WORA, which means write once, run anywhere. WORA. Okay, so I think are everywhere. So write once and run everywhere. So that's what Java is. That's kind of the main advantage of Java. Okay, so that's it for this video, and that's it for this course. I hope you enjoyed it, and I see you in a future programming course. Thanks for watching. Bye.